All right, give a round of applause to Prasenjit.
All right, cool. Okay, good evening, guys. My name is Prasenjit Sarkar. I am a product manager within Oracle Cloud Infrastructure. And today I'm going to talk about this multi-stage Docker build to create an effective and secure container and a much more smaller image, which is of course a much more smaller attacker surface. And then how you can build a small image and for building that, and then pushing and pulling as well, because that requires a lot of runtime. So who am I? I'm a product manager. What I care about is these are the technology stack that I'm really passionate about. It's Docker, Python, Kubernetes, Istio, Jenkins, and OpenFast. My Twitter is a Stretch Cloud. That's what I tweet at most of the time. All right, so multi-stage build. How many have you already seen or used a multi-stage Docker build file? Almost 40% people. All right, that's good. So of course, multi-stage build equals to layers. And we will copy those layers where it matters the most. And then how efficiently we need to write those multi-stage Docker build is something that I'm going to go through. So Docker images and layers, it's like you have the container layer, which is RW, and then you have your image layer, which is read only. And then you have your container runtime. So let's say you use the Ubuntu 15.04 or 16.04 or 18.04. And then you have seen those image layers, which are read only. And then on top of that, you have your read write layer. So that's how the layer works. Now, why it is so important? You will add more layer. It is going to increase your image size. That's number one. Number two is large image not only takes time to build, but also it takes time to push to your Docker image repository. Doesn't matter whether you use hub.docker.com or your own secure or private Docker repository. If you build much smaller image, then you will not only reduce the build time, but also you will reduce the time to deploy either in a standalone or in orchestrated environment, which is Kubernetes in this case, what I'm talking about. And small image is, of course, the small attacker surface. That's why we need to build smaller image and effective containers. Docker multi-stage. So what is that? Now, Docker will allow multiple from statements. So when has that been introduced? Is 2 years back, I think 2017, somewhere around February, June timeframe. It was merged in a pull request and then has been pushed into 17.05 release. Since then, we are using multi-stage build. But before than that, we were, rather around the same time, we were using we were using builder pattern to create effective or smaller Docker container than the multi-stage build. But it was a really, really hard process to go through. And that's why we came up, or rather Docker came up with a multi-stage build. So each from statement marks a start of a new build context, which is assessed by the number or a name that we are going to define. I'm going to show you how to do that. Each new context, which is the from, is like starting a new Docker file. And you then copy what you want from any previous context into the new context, and whichever is the last from statement as the base or as the final base image. So for an example, you take a distribution, which is, let's say, CentOS, and then you install Python on top of that. So when you install Python on top of that in a particular working directory, you just copy that particular directory to the next image layer and leaving all that other crap outside, because you don't need other libraries, you don't need other build times, you don't need other run times. You need only the run times or the library that you need to run your Python API code or whatever the application that you're built for. So multi-stage builds versus the builder pattern. So this used to be earlier the case, the builder pattern. So multi-stage build, as I said, it is the separate, we are separating the stages in a single Docker file, and you can copy the context from one stage to the other, and the resultant is going to be a much more small final image. The builder pattern is the build, then copy the artifacts over, and then the results is a small image, but it's a more complicated process, as I said. End result is often something like dockerfile.build and dockerfile.final, and then you have a multiple Docker file. But in the stage of Docker multi-stage build, we're going to have just a one single Docker file, and we will use the from statement to copy the context over and over to the next layer. So what is build context? Now, every build context is something what you are sending to the Docker daemon to build that. So for an example, when you are running a run command, and then you are installing something, for example, you're installing the common tools, you're installing, let's say Python, you're installing some of the, security tools or any other library that you want to build out your stuff. When you do that, you're sending out the context to the Docker daemon. When you look at the log, you'll get to see that what you're actually sending it from your local box where you're actually building that Docker image. So when you run Docker build and then -t and then your name of that, when you're tagging that, and then dot to show the Docker file, when you do that, it's going to send a hell lot of stuff to the Docker daemon. And that's the size of your context. So whatever you are sending, you just be mindful about that size is you're sending it to the Docker daemon, and that needs to be processed within your local box, right? So that's basically your build context. The more context that you send to the Docker daemon, the bigger your build context will be and the larger your image size. You need to avoid unnecessary files and directories, such as, for an example, .git. If you are using _py cache, sometimes I use the py cache to send it to Docker daemon as well. Just copy dot to dot or my directory, because I want to run, I want to have my py cache within the container, so that it can pull up from the Python cache and then run my code much faster than building it from the code itself. So, all right, now I get it. Yeah, that's about the multi-stage. Now, when did they merge the pull request? Yes, that's a happy day. So look at the time and date. So that was around March 24th, 2017, when they build and pushed that PR with the build number of 1705. So it's been there for a little more than 2 years now. So that's about the problems that we have talked about. Now, what about the remediation? What should we do to create that image? What should we do to create that Docker file and then send it? And then also be mindful about the security. Now, somebody has talked about rootless Docker. So we need to be mindful about the user context as well. So let's look at that. So we need to start from a lighter base image. What is lighter base image? Lighter base image based on your need. For an example, do you need, so let's look at the base image and the distro, and let's look at the operating system and the distro that you need to be using, and what's the size for that. So be mindful about what is written on your writable layer, your chain run commands, as each run creates a layer. So we'll be talking about the run command that you need to run within the Docker file. So one run command creates one Docker layer. That's a read-only layer when you build that one. But if you write that one, the one single run command, and then you do an ampersand, and then run another command within the same run command, the entire run command is going to create just one single image layer. So if you're installing, let's say 10 different stuff, try to do that within a one single run command than running it in a 10 run commands. If you do that, 10 different image layer, 10 different image layer will add up the space, add up the build times, the push times, and the pull times as well, right? And then, prevent the cache miss at build for as long as possible. Now, the Docker build. So Docker file, as we know, that is a series of instructions for building an image. And after each Docker build command, you will get a single image layer. And complete the Docker build execution generates a single Docker image. So so it will flatten out the entire stuff and then we'll create one single image layer at the end of the day. So let's look at the base image, but base image may not be the optimal image that you are trying to use in your use case. So be very mindful about what you're trying to use. So here, I'm showing you an example what I have built for this demo yesterday. So I'm using a flattened, it's not a multi-stage build, it's a flattened Docker file. So I'm using Python latest. That's an image, that's a distro that I'm using. And if I use that to create and run my API, REST API that I have written, then my Docker file size, which is this, is 979 MB. It's enormous. Think about a slow network where you need to push and then pull into your container run orchestration layer, let's say OpenShift or Kubernetes for that matter. It is going to take much longer time to do that. So be very mindful about what you're using as your base image. It may not be the optimal image, but can you choose another image to host and run your application? Of course you can. Let's look at that. So what I have used here is a quick command to show you the size in MB of a base image of two different distro. The number one distro is using Python latest, which is fine. And the size is 875 MB, okay? When you use Python and then the tag is 3.7, which is the latest one, and -slim, if you use a slim distro, then it's going to use 136 MB. Look at the difference. Can you use slim? Maybe, of course, it depends on your use case, but most of the time, yes, you should be able to. So that's choosing the right image. Now let's looking at the right distro or distribution of the image. So what operating system should you choose? Should you choose Ubuntu or Alpine or Debian or Oracle Linux or CentOS? Look at the size for everything that I have pulled yesterday. So Ubuntu is 64 MB. Alpine is just 5.58 MB. Debian is 114. Oracle Linux is much more, which is 235. And CentOS is 202. So it looks like the Alpine is the best one to start at, right? So we may start choosing Alpine, but Alpine comes with various different complexities as well. So when you try to, let's say install or switch a user context, think about the commands. Not all the commands in different distros will work with an Alpine Linux. So, but wait, do we really need to have the full operating system? It depends on your use case. You may really need to have a full operating system. What are those use cases? For an example, you want to run the full image of security. Or for an example, if you have a compliance matter where your security team has already certified an image saying that this is the distro that we'll be using for auditing purpose. Fair enough. Go for the full image, full operating system. And of course, the developer friendly, because the full operating system will come up with a lot of tools, the libraries, the common tools, the development tools already built in. So developers should not really think about or worry about how do I inject my tools within that? What are the commands? How do I switch the context and do that? Because everything is built in, right? So of course, so these are the use cases where you really need to use probably a full operating system. Can't help it. Problems with the Docker build. So what you actually want is your application running on top of Docker. And that's about it. You really don't want a compiler. You really don't want your test code that you have pushed into the GitHub or probably in your local directory. You really don't want your build or test log or reports. So easily, these three can be chucked out in a multi-stage build. And you just need to care about your application running on top of Docker daemon. That's it, right? So what is Docker multi-stage build is, let's look at the benefits. So it's a single Docker file, unlike the builder pattern where you may end up having 2 or 3 different builder pattern files. It's a one single syntax to learn, which is from, and you create multiple stages for that. And these are the kind of, the base image, the compilers, then linkers, and, the testing, and then the final release within a single Docker file. All right, so let's look at my example, what I have done for this demo. So I have taken Python 3.7 Slim as my base image, which I named as Python-base. Now, from that, I started building out my dependencies within that image. So building out the dependencies is nothing but I tried to copy the requirements.txt where I'm installing the Python modules using pip. And then I'm running that with that command, run pip install -r requirements.txt. And that's about it. I just install the dependencies within that. And I have done nothing within that container or that image layer. Now on the next layer, I'm saying from the dependency as a build, then I'm trying to copy my program files, which is app.py, csvinsert.py, titanic.csv, dataimport.py, and then I'm copying the Swagger YAML file as well, because I'm exposing my API as a Swagger interface. And then I'm creating a user so that at the end of the day, I'm going to run that under a user context rather than a root context, because I really hate somebody to access my container from a root context and do something with that. I really want a normal user to run that within a user space rather than a root namespace. So I'm creating a user and a group, and I'm running a Python script all in one single run command. It's just been stacked together so that everything has been just in one single layer. Once I'm done with that, then I'm saying, now I'm going to create my final release image. With the final release, I'm just copying from different layer what the context is going to matter for me. So first is I'm copying my dependencies where I have already installed my Python modules. Then then from the dependencies, I'm copying the root cache where my actual Python modules have been installed in the other dependency layer. And then I'm starting my data import, and I'm exposing this to my 5000 as that's a Python Flask API, and entry point and a command. That's it. And I'm running that under user app that I have built in two previous layer. What is the image size that I have created? Is no, sorry, it's not there. So the image size for this is 120 MB. From 975 MB, I built an image which only matters to me is 120 MB, right? So multiple run, as I said, is equal to multiple layers. So multiple layers means multiple image. I mean, the image size will grow up. So you need to just stack up your run command, which I have done in here. So I'm installing, pip install upgrade. Upgrade the pip, I always do that, and then pip install requirements.txt, then I'm adding the user, the groups, and I'm installing the SQLite because this is a Python API which is using SQLite database. And then I'm starting my data import, I'm injecting a data and importing a data, and then I'm starting my actual application under the user app, which is the user context. Now, probably you may not be able to run under the user context of app. So you still need to install all of the software using a root namespace. So let's look at that. So user switching equals to more layers, right? So if you run everything under the user root to begin with, you install everything under the user root, and then you expose your application using your own user, that means you are switching the user context. When you switch the user context, every time it's going to create another layer, more size, right? And then the builder flags that you should really know about. You can use the cache from another image to cache from if you really want to do that, because sharing is caring. So if somebody has already created an image where everything is already built up, so you can use that as a cache image. So you can use that. You can use compress to compress the build context, and that's using the gzip. And no cache, you can ignore the cache, and then you can use squash new layers into a single layer, which is going to be flattened enough completely at the end of the day. And yeah, so this is, by the way, this Squash, even until yesterday or even till today, it's in experimental mode. The API is API 1.25 plus. It's still in experimental mode. And in my case, the way that I have built my image, it did not do much when I flatten it up totally into one single image. It just saved just 2 MB from 120 to 118. And that's about it. Any questions?
So do we have any actual questions before we are very, cool? Because the aircon switched off like half an hour ago. And I really want to go outside.
Yeah, thank you very much. I basically have 2 questions, and that's related to Python. Did I hear you correctly when you said we should remove the Python cache when we're deploying onto Docker to reduce the build size?
I have to go give it back because otherwise it will be on non-video.
Yes, I said that so there are times where I really need that Py cache inside my Docker container. And there are times which I really don't want. Depend on how fast I know that how it is going to be compiled within the image and how fast I want my application, in this case, a REST API, to just spin up. In my case, I really did not care because it's a demo application. So I don't probably need Py cache to be injected into the container because it requires a more size and of course, the build times. So sometimes I do that. Sometimes I don't, depend on what exactly I'm trying to run. Your next question, please.
Deploying Python applications onto the web, not necessarily with Docker, but with one of your products, WebLogic, with WebLogic domain, we try to slim down the build process by removing the cache and the application, the functionality of the Python application, ceased basically. And the iteration levels for it to work meant that we had to bring back the cache. Because remember that Python is not a compiled language. It's interpreted and sits on top of the JVM. Does it have the same impact on a Docker container when you remove the cache? Have you noticed any difference?
So the question is, in WebLogic case, when you run that, when you run that on top of JVM, it's basically a Python script, and then Python is looking at the Py cache to spin up that entire process, and it freezes when it is not able to find the Py cache. And in my case, whether I have seen that situation or not, unfortunately, I haven't seen that because the applications that I have built or the code that I have written really doesn't care about whether I have a Py cache or not. Maybe it's going to be 2 seconds faster, but who cares? It's not a WebLogic anyways. It's not an enterprise grade applications. I'm not an app developer no more. I'm no more app developer right now. But the kind of a demo that I write doesn't really matter whether I have a Py cache or not. It's pretty small, and it just spin up and then do the stuff that I really want to show, the integration in between the ecosystem, and go from there. 235 MB.
One last question, and then I really want to go.
So you mentioned about having multiple runs and how that adds multiple layers, which delays the build process, which I've experienced as well. I'm just wondering if you've experienced with this, because I've seen this done in a better way, in the sense that when you do a run, instead of running all of your commands with end, you can just create a script. Yeah. To me, it makes the Docker file cleaner, and it's easier to follow. And when you're doing a run with loads and loads of installation steps, it's like there's an indentation problem sometimes. You need to be really careful of how you do it.
All right. So Yes, from a look and feel perspective, yes, it looks much cleaner. But if you are a developer and I'm a developer, I would really love to see what is there in your script rather than, I mean, of course, I can see that because that's there in your folder where you are running your Docker build command. I can look at that file, which is okay. But then when I'm looking at your Docker file, I mean, as a developer, I would really love to see what you're trying to install to give you feedback, whether do you really need that or not? Because in a lot of cases that I have seen, when I push that code out, and if there is a better way to do it, and if I don't need a particular runtimes, I have been given a feedback into my issues, GitHub issues, saying that, you know what, you really don't need that, and I did not know it. So when you build that Docker image, and then when you share that with somebody, and then when you push that code into the GitHub, if you have a script, people will not able to know that whether that script, what contains within the script. Absolutely, that's the case. Yes. So she said that you can have the script file within the same repository, within the same tree, and then push it to a repository, whatever you like for. And people will be able to see that. Yes, technically, all you're saying is possible. It's all good, but it's a personal choice that I'm saying is that I really love to see what's written on the Docker file rather than going multiple here and there to see whether the script looks whether the script there or not. It looks clean, to be really honest, but absolutely. It totally depends on that, how much run you are running within that container layer.
Thank you so much. Well, that concludes our July edition. Thank you to Prasenjit, to Anna, and to Josh. Round of applause. Thank you to Babylon for hosting us. And yes, right. And let's just go to the pub right now. Follow John, we're going to the Hourglass. If anybody wants to take the pizza and disperse it to anyone they might need it most or something, if it's still left, then please take it with you.